You know what the best hamburger is? Not to go off on a sidetrack, because I never ever do that. You get a good hamburger. You put lettuce, tomato, but then you put a fried egg and bacon on it, and hash browns. It's not that big, but no, a good. You take a burger, hash browns, fried egg, so it's still a little bit gooey. It's bacon, it's lettuce, tomato. You can. There's a place in in Geneva, right next door to the running store, that they have those burgers. They're half off on Sunday, so like $5. Anyway, so I'm looking at Snack Bar. Snack Bar talks about your objective is to make some money. You make 33 cents per hamburger plus 21 cents per hot dog. Bless you. 12th hour, a couple people asked. Guys, 12th hour, a couple people asked the question in regards to, do they have to put it as 0.33 or 0.21, or can they just say 33 cents, 0.1 cents? Perfectly fine, because then your answer would have been, 718 cents, which means it's 7. It's not a big deal. Just remember that that's what your value is. From there, you had constraints that your 10 less than or equal to the burger, less than or equal to 40. 30 less than or equal to a hot dog, less than or equal to 70, and then burgers plus hot dogs had to be less than or equal to 90. Since I put burgers first, excuse me, that's going to be on my x-axis. Hot dogs were up here. And then, did you guys start to realize why I put the farther intercepts out first? When we set your farthest intercepts out first, you can work backwards for your scale. And it's usually a little bit easier, okay? As opposed to putting here's 10, here's 40. If I do it as, well, I know that I'm going to have a 90 out here and a 90 up here. Okay? You all right with that? If I go to the B values for my verticals, because they're playing the role of the X, what I would do is say that, hey, the 40 is pretty darn close to about halfway. So if I'm guesstimating halfway-ish, I'd say it's about here. And then 10 would be about there. Just kind of rough sketching. Now remember, when you have those verticals, that means that that value of X, or in this case B, it stays constant throughout that vertical line. So that means if this is 40 here, this is going to be 40, comma, what? It intercepts the 50. Very good. It's going to be 40, 50. Because it's hitting that line of X plus Y is 90. Okay. Same deal here. Oh, that's not straight. Yeah, there you go. So that means this is at 1080. So far, so good? All right. Now, the next one I have 30 and 70. The 30 is pretty straightforward. It's about a third of the way up. 70 is a little bit more. Now remember, what's nice about the 70 is that you know that that Y value is at 80, so it has to be below it. Does that make sense? And that's what I mean by trying to figure out where your scales wind up. So this is going to be at 1030, 1070. This will be 2070. This one will be at 40, 30. And I believe that it goes here, here, here. I think it was to that region, if I'm not mistaken. Excuse me. Most people that I saw that were working on this one throughout the day yesterday got that 2070 point outside of the region or that 40-50 point outside of the region because of the way that your scale was drawn. So just be cautious when you do that. It's a very, very easy thing to mix up. Okay? Any others on this one that you want me to walk through? Which one? The filing cabinets? Okay. All right, filing cabinets. So on the filing cabinet one, we're looking at you need to buy some filing cabinets. You know that the cabinet X costs $10 per unit. That's a cheap filing cabinet. And it requires 6 square feet of floor space and holds 8 cubic feet of files. That's a big cabinet. 6 square feet of floor space. That's 2 feet by 3 feet. That's 3 squares almost. 2 by 3 squares-ish. It's a big thing. Cabinet Y is $20 per unit, 8 square feet of floor space, holds 12 cubic feet of junk. You have $140 to purchase, and you don't have, and you have, your office can have no more than 72 square feet of cabinets. Okay. How much each should you have to maximize storage capacity? So your goal here isn't to spend money, make money, save money. Your goal is to maximize storage. Now, I don't know about you guys, but I've had to buy a refrigerator in my life. I've had to buy a washer and dryer. Very good. Now, when you buy a refrigerator, washer, dryer, something like that, they are set at different capacities. Capacities is how much crap can you fit in there. So refrigerators are, regular side-by-side refrigerators are usually 26, 27 cubic feet. Washing machines, depending upon the type you have, are between, some front loader ones are about 3.5, top loaders are around 5.5 square feet. Cubic feet of storage space. Dryers, on the other hand, it's weird. A wash machine holds holds less. Wash machines hold less, they're about 5.6 cubic feet, whereas a dryer might be around 8. And that's the reason, so that way you get movement in the air when you go through it. So what you're looking at here is you're maximizing the storage capacity. How much crap can you fit in there? That's volume. So you have volume of X is what? 8 cubic feet for X plus 12 cubic feet for Y. That was my objective function. All right. From there, you talked about money. In the case of the money, you have up to and including $140 to spend. And cabinet X, it's nice they call it X and Y, isn't it? Cabinet X costs you $10, whereas cabinet Y costs you $20. From there, we had square feet. We had 6 square feet for X, 8 square feet for Y, and 72 square feet total. Okay. Obviously, this is a first quadrant problem. Can't have negative cabinets and/or things. Am I going to yell at you if you don't put that down? No. Nope. Sir. Not really, to be honest with you. Most of our stuff, I think we had one example where we had an x-intercept that was negative that came up. Remember that? That's like the worst case scenario. Most of these things, because you're talking about maximizing profits or even minimizing costs, you can't have negative costs. You can't have negative sales, but you can have a graph that starts with a larger y-intercept that has a negative x that comes up through. That's the worst that it could. So now you know your first quadrant problem. Gee, what am I going to call my x and y? X and y. That's kind of nice. Did any of you guys simplify these equations prior to getting your intercepts. You did? You put it at 1x plus 2y is, what would that be, 14? X plus y, or then you 3x plus, I mean, you can simplify these down a little bit if you wanted to. You don't have to. If you get, they're all very, very easily workable numbers. So I know that I have intercepts for the first ones at 14 and 7. Is that moving inward or outward? Inward. The next one I have intercepts at 12 and at 9. And this one's also moving inward, which means I have to find that intercept right there. Okay. So when I find the intercept there, I'm going to do the following. X plus 2y is 14. I just simplified this equation real quick. Took out the 10. And I'm going to say x is 14 minus 2y. Substitute in the other one, we'll have 6 times 14 minus 2y plus the 8y is 72. I get y is 3 after manipulating a few things. Okay. If y is 3, 3 times 2 is 6. 14 minus 6 is 8. And that gets me my 3 sets of ordered pairs. Obviously, I don't want to technique 0, 0 because I kind of want to be able to store my crap. And if I don't have any cabinets, I can't store anything. Oh, my word. Yes, multiple cubic feet of piles. And that's how we go. Do I have to substitute in, or are we okay? They're not bad problems, are they? They just look awful. Where are you going with this one now? Are you gonna pump up the jam? Pump up the jam? Dance, dance. That was Mars. It's a song from Mars. It is old, yes. You know why? Because I'm old. The answer winds up being when you substitute in your threes, because obviously we don't have to worry about it 0, 0. You're going to test it at 0, 7, 8, and 3, 12, and 0. When you substitute all the way through, you're going to have 0 plus 12 times 7, 8 times 8 plus 12 times 3, and then 12 times 8. And I believe the one in the middle worked out to be the maximum storage. Biggest bang for your buck. No, it's the same. You never heard that before? Sometimes I'm actually serious. You could really even say that without even laughing. All right, let's try some. These are fun. Yes, so much fun. As much as you have, I like this thing here. I kind of enjoy doing taxes. You know why? Because as you start to fill this stuff out, you start thinking like, okay, where am I going to save money? Where am I going to save money? And then all of a sudden you realize, okay, I can do this, I can do this, for this house. You start seeing the money coming back, it's tangible. And when you use the terminal tax, it says, you're paying back. Yeah, I understand. Not paying taxes is a very, very smart thing to do. What's funny is that as a kid, as a kid, I had my first job pretty much when I was in like fourth, fifth grade. I had paper route, then I was a busboy, dishwasher, so I've been constantly working forever. So as soon as you started having to, get a job, you're getting real paychecks, you have to pay taxes. So my parents, my mom used to help me out with my taxes, because I don't know if you guys probably had to fill taxes now, but before we had this great thing called the internet, which I understand are on computers now, you had to do your taxes by hand, then you had to fill out forms and mail them in. Well, my taxes were like, I made $3,000 one year, and I had to pay taxes and get a refund and whatever. Yes, ma'am. I can't count to 6. I only have 5 fingers. Just admit you don't like it. So sure. He's so quiet back there. All right. Yeah, they do. Oh, did everybody? Oh, that's a copier. Job unbelievable. I don't know what that means. All right, anyway. So I think the only thing that's weird on this one, that's anything different than what we've seen so far, is it on the Oaken Treasures. Yeah. Oaken Treasures make 2 different kinds of chairs, rockers and swivels. Now, wouldn't it just make sense to make a rocker swivel? Guys, rocker swivels. Rocker swivels are just these. Yeah. Swivel. All right, I get it. It doesn't rock like we all like to rock. All right. The puns are not very punny, so. What? Yeah. What? I don't get it. Who's like? No offense if any of you guys run student council. I think what you guys do in student council is a great thing. But come on, meme day? I don't get it. You're an idiot, but that's okay. All right, here's an apologetic high five. For a brief moment, I did think. All right, anyway, let's get back on task because we never get off task. Anyway, chairs, rockers, and swivels. They work on machines A and B required to make all kinds of chairs. Machine A can run no more than 20 hours a day. B limited to 15 hours per day. Chart below shows the amount of time each machine is required to make 1 chair and the profit from each chair. How many chairs of each kind should Oaken Treasures make each day to maximize their profit? It is. So your objective is that you make $12 per rocker and $10 per swivel. And that's what's weird about ones you see that are given to you in table form. You're going to start thinking that you have to talk about in terms of machine A and B. Where machine A and B are the constraints, whereas the objective is brought to you in terms of chairs. Okay? So what we'll wind up doing here is we're going to have rockers and swivels. You know what? I really enjoy writing word problems and coming up with different ways to write them. I really want to make you guys laugh at some of them because I know the stress level on word problems starts to get a little bit higher than like 12. So if I can get you guys to like relax and laugh at the stupidity of some of the words, it relaxes you. So feel free to laugh tomorrow because I try to make it funny. What's that? right, so constraints. Machine A can only work up to 20 hours a day. Machine B can work up to 15 hours per day. The rocker needs 2. The swivel needs that one. Oh, sorry. Swivel. Yes, I am. I have some, when we get to, all right, quadratic word problems are absolutely hysterical. Because what does a quadratic function look like? Remember? It looks like a U. It's like they're up like a cup or down like a frown. What goes up must come down, so there's a lot of like rockets being shot off, and someone's kicking a ball, someone jumps from the top of the building upward and falls down. No, like you have a flop shot, golf wedge, you know. Initial velocity. Your GPA. I just wanted to make sure you guys saw how that works off the table. It's a little bit weirder to see in table format versus reading it in words. I think it's easier to read it in words than it is in the table. For some reason, my mind doesn't think in tables. I think of more like islands. Yeah, it's tables and chairs just mess me up. That's why I do a lot of my work on my kitchen island.
You just like stand.
No, I have a stool. Yes, I'm scared of chairs. Ah, chair! I don't understand. I'm only a. Have you guys ever seen Caveman Lawyer? Start working and I'll find you, Caveman Lawyer. I don't understand your ways. I am just a caveman. How do you not know these things?
Hey, it's 1 century, mind you.